Welcome students, we've been given this question, integral 0 to infinity ln of x raised to the power of 2n negative 1 divided by x squared positive px positive 1 times dx. N is element of positive integers and the value of p lies between negative 2 and 2. So these are the boundary conditions. We are expected to integrate this. So foremost, what I wish to do, I would like to take let I be equal to integral 0 to infinity ln x raised to the power of 2n negative 1 divided by x squared positive px positive 1 times dx. Now I would like to make a substitution. I will say x is equal to 1 over t. So if I were to differentiate, I get dx is equal to negative 1 over t squared times dt. When I need to set up the limits, when x is equal to 0, if I were to substitute x is equal to 0, t will be equal to infinity. When x is equal to infinity, the value of t is equal to 0. So this is important. So having got all of this, let me move on to the integral. So I'm going to write, therefore 1 can be rewritten as, on the left I got I is equal to integral 0. In place of 0, I substitute infinity. In place of infinity, I substitute 0. This is ln of x. X is going to be 1 over t. So 1 over t, this is raised to the power of 2n negative 1. And this is divided by x is equal to 1 over t. So 1 over t squared positive p times 1 over t positive 1. In place of dx is going to be negative 1 over t squared times dt. Now what I wish to do is, first I would like to move 1 over t to the numerator. So 0 to this is infinity to 0. I will change the limits later on. Infinity to 0 ln, this is t raised to the power of negative 1. This is in turn raised to the power of 2n negative 1. Now this is divided by, now you can take the LCM. Now let me just consider this 1 over t squared positive p over t positive 1. I'm taking the LCM as t squared. This will give me 1 positive p times t positive t squared. And that's exactly what I'm going to substitute here. So 1 positive p times t positive t squared divided by t squared. And that is multiplied with negative 1 over t squared times dt. Now what we can do is we can use the law of indices. A raised to the power of n raised to the power of m is equal to a raised to the power of n times m. So by that property, what I can do is I can multiply these two indices. Now if I were to do that, this is going to be integral infinity to 0 ln t raised to the power of negative times 2n is negative 2n. So I will just take it like this, right? I can rewrite a raised to the power n times m as a raised to the power n times m, right? So I'm going to rewrite it like this, negative times 2n minus 1. I don't want to disturb this index, so let me keep that index. Now in place of, or I should say instead of writing it as negative, I will write it as negative 1. Fair enough, right? So this is divided by, now this component can be flipped. So if I were to flip it, t squared will go to the numerator, divided by 1 positive p times t positive t squared times 1 over t squared. You got a negative sign, so let me retain it as it is, dt. T squared can be cancelled. Now I got a formula, ln a raised to the power of b is equal to b times ln a. So by that, I'm going to push this negative 1 to the front of ln. So that will give me negative ln times, I'm not going to touch this index. I'm going to retain it as a ln t raised to the power of 2n negative 1 as it is. Now let me place this limits. This is infinity to 0 divided by, I got a negative sign here, so negative sign, there is a negative sign here, so okay, let me rewrite this. So let me write it as dt, negative dt, divided by 1 positive p times t positive t squared. Now negative negative will become positive, so I can place that positive sign, and what I wish to do is I would like to revert this integral. Instead of writing it as infinity to 0, I'm going to write it as 0 to infinity. So that would mean there is a negative sign there, negative there. So I'm placing it as it is. And followed by ln of t raised to the power of 2n, negative 1, divided by 1 positive p times t positive t squared times dt. So this is what we have got. Now let me rewrite this as negative integral 0 to infinity ln of t raised to the power of 2n negative 1 divided by 1 positive p times t positive t squared times the dt. Now what I wish to do is I would like to make one more substitution. Let t be equal to x. I get dt is equal to dx. So this is equal to negative integral when x is equal to, let me put in that, when x is equal, or I should say when t is equal to 0, x will be equal to 0. When t is equal to infinity, x will be equal to infinity. So there isn't any change there. So this is going to be negative ln x raised to the power of 2n negative 1 divided by 1 positive p times x positive x squared times dx. Now what is this? I've taken this to be as I, right? So this is going to be equal to negative I. So what you got on the left, I. Push this. So it's going to be 2 times I is equal to 0, right? When this comes on the right, you get 0. Now what is this equal to? This means I is equal to 0. Now what does this mean? This means integral 0 to infinity ln x raised to the power of 2n negative 1 divided by x squared positive p times x positive 1 times dx is equal to 0. So that means we have now obtained the result for this, and to get this result we have followed the following steps. Now I have a question for you. Since that I've got the result, my question to you is, if this quantity, this integral is equal to 0, means what does it talk about the function, or what does it tell us about the integrand? Can you put them in the comment box? I would be waiting for your answer. Thank you everybody. Please like, share and subscribe to our channel. Until we meet again.